Okay, let's look at balancing equations. So a couple of things. Let's look at an example. If we have solid magnesium plus oxygen gas yields solid magnesium oxide. This is why it's important for you to know all of the names of these things. So if we have this, the things on the left-hand side, just a couple of conventions, we call these the reactants. We call the things on the right-hand side the products. And then we refer to this arrow as yield. So we read this reaction as magnesium and oxygen yield magnesium oxide. All right, so let's talk about balancing this. So in any equation, we need the same number of atoms on each side for every single type of atom there is. And we're going to start with the thing that's the most complicated and investigate that first. And we're going to have to go from the left-hand side and the right-hand side back and forth until we get the balance that we need. So magnesium oxide has 1 mole of magnesium, or 1 magnesium atom, and one oxygen atom. On the on the left-hand side, we have 1 magnesium atom too. But we have 2 oxygen atoms. So we know that we're going to have 2 moles of magnesium oxide because we have 2 oxygens on the reactant side. Now, if we have 2 moles of magnesium oxide, then that means we have 2 magnesiums. And so we need to put a 2 in front of the magnesium that's on the reactant side. Now I think that we have a balanced equation here. So we're going to check. We're going to look at the number of atoms on each side. On the left-hand side, we have 2 magnesiums and 2 oxygens. And on the right-hand side, we have 2 magnesiums and 2 oxygens. So I want to say just a couple of things. The first thing is that I wrote the states here. And so you should be familiar with writing the states of matter. So solid, S, liquid, L, G, gas. And then there's another one, AQ. AQ stands for aqueous, and it's talking about something that is in a solution. So we haven't covered solutions yet, so you might just think about things that you know dissolve. So for example, if you put sodium chloride into some water, you would know that the sodium chloride would dissolve, and so we would say that the sodium chloride was aqueous in liquid water. So that might be helpful to know before we start our solutions chapter, which is chapter 4. So anytime you're dealing with water, it's going to be in the liquid state unless it's otherwise specified in a particular problem. And then if you're combining it with something that is an ionic compound, so something that's a salt, something that dissolves, that compound is going to be aqueous. That might be helpful for some homework problems. Okay, so let's look at a more difficult balancing equation type of problem, because the one that we just did was too easy. So let's look at this one. We have C8H18. I'm not going to write the state just because it takes up a lot of room and it's kind of hard to write on a tablet. Plus O2 yields carbon dioxide and water. Now this is a combustion reaction. We know it's a combustion reaction because you have some sort of hydrocarbon reacting with oxygen to produce carbon dioxide and water. And so we're going to look at the thing that's the most complicated first. So there's 8 carbons on the reactant side, and there's only 1 carbon on the product side. So we need to put a coefficient 8 in front of this carbon. On the reactant side, there's 18 hydrogens. On the product side, there's only 2. So if we put a 9 in front of this water, the coefficient 9, then we would have 18 waters. So now let's look at oxygen. So first we want to look at the number of oxygen atoms on the product side. So on the product side, we have 16 plus 9, that's 25 oxygen atoms. Now on the left-hand side, on the reactant side, we only have 2 oxygens. So we need to think of a way that we could make the oxygen the same on each side. So one way to do it is to put the coefficient 25 divided by 2 in front of oxygen. And then we are going to multiply each coefficient in front of each molecule by 2 to get a whole number. So when we do this, we say 2 moles of C8H18. This is octane, by the way. You don't have to know that, but so we have 2 moles of octane plus 25 moles of oxygen yields 16 moles of carbon dioxide plus 18 moles of water. Now we want to check and make sure that we have the simplest whole numbers in front of each whole number coefficients in front of each one of these molecules. So we want to make sure we can't divide them all by something to make them smaller. And you know, the key to that is looking for something that maybe is an odd number, because you can't divide odd numbers by 2 evenly. So if we had 2 moles of octane and 25 moles of oxygen, there's nothing that these two numbers, 25 and 2, share that could make them be reduced any further. So this is the correct balanced equation for this particular reaction. Let's do another one just to get the hang of it. So let me make up another one. Maybe I can get one from your book. Let's do this one, C3H8. This, by the way, is propane. O2 yields carbon dioxide and water. Again, another combustion reaction. Let's look at the thing that's the most complicated. So let's look at propane first. There's 3 carbons in the reactants, so we want 3 carbons in the products, so I'm going to add a 3 in front of carbon dioxide. There's 8 hydrogens in the reactants, so I'm going to add 4 in front of the water. 3 and 2, we have 6 oxygens on the product side, and then we have 4 oxygens from water, so there's 10 oxygens total. And so since this is an even number, and then we have 2 oxygens on the reactant side, you know that you can multiply 5 times 2 to get 10. So now we should have the same number of everything on each side. So let's confirm that. We have 3 carbons on the reactant side. We have 8 hydrogens, and we have 10 oxygens. Let's double check. We have 3 carbons, we have 8 hydrogens, and we have 10 oxygens. So we know that we have a balanced equation.